Hello, today is about transformations. So I wrote on the board part of the icons. The icon draw, and we're going to concentrate on that using notation for reflections and translations. Those words you originally heard of as turns and slides and flips. But here's some fancier wording. We also are going to be uniform if we have originally the letter A or a point. The original is called the pre-image, and it has rigid motion. Rigid meaning all sides the same, all angles the same. So it's rigidly keeps the same size. But the motion is the transformation. The specifically reflection as a transformation or translation as a transformation. A fancier word for rigid motion they sometimes will use is isometry or isometric. So basically, we're going to start with a coordinate plane, and we'll have a specific point. Say we started with 1, 2, 3, negative 1, 2, and labeled it A. And we decide we're going to reflect. And when you reflect, you always have to tell me the line of reflection. So over the x-axis. Okay. This is y, and this is x, so it would flip up, wouldn't it? So the rule would be that whatever this is, and this is 3, negative 2, it still would be 3 to the right, wouldn't it? The x part of the coordinate stays the same as it flips over. But the y is no longer negative, it's positive. The y becomes the opposite. In the book, instead of saying reflect over the x-axis, it will abbreviate with r x-axis. So the r for the y-axis, the original xy. So let's use the same point. Oh, so that went 3, positive 2, didn't it? This next one, if we reflect over the y-axis, it goes left and right, doesn't it? So no longer is it 3, but it's opposite of 3. A prime was our first one. Now we're doing A, and it's 1, 2, 3. So when it flips over the y-axis, it's still down 2, isn't it? Negative 3, negative 2. This time our A prime was opposite x and the same y. Okay, there is one more reflection that they use a lot, and instead of x-axis or y-axis, they do a specific line, and they could give you x equals 4 or y equals 2, and you could reflect over it. But one they also use a lot is the y equals x, and that line, where does y equals x? Well, 1 equals 1, 1, 1, or 2, 2, or 3, 3, or 4, 4, or negative 1, negative 1. This is the line y equals x. So looking at that same point, if we start 1, 2, 3, negative 1, 2, and flip it over, this time goes sideways and ends up over here. Goes up, and there. And to see exactly X, Y, so it was there, ends up here. It technically does Y, X. So if it was 3, -2, then it is flipped -2, 3. -1, 2, 1, 2, 3. So this way is at a perpendicular. So the rule, if it goes over that line, is that they just flip. There is one more that we'll look at, is the translation. That's just a slide. So to do a slide, they don't tell you the line that it's going to flip over. They tell you how far and which way. How far and which way. So they typically, translation, T instead of R, we call this H, K. So that basically says X, Y, moves X plus a certain number or minus a certain number, and Y plus a certain number or minus a certain number. So if we were saying that we were going to go left 3 and up 8, it would be T left 3, -3, up 8, +8. So the XY would move X -3, Y +8. So for example, if we started at 1, 1, if our original was 1, 1, then 1 - 3 is -2. 1 + 8 is 9. Our point, -3, 8, would move to the left 3 and up 8. Wait, I started at 1, 1. What am I thinking? Here's 1, 1, and then left 3 and up. So it makes sense. Left 3 and up, left 3 and up 8. It ends up at -2, 9. And that's the basics. You should understand more as you do the problems in Pearson. Thank you.